Howdy once again, it's tubalcain, your humble YouTube shop teacher, and this is video tips number 485 entitled Large Hole Saws Run at Slow Speed. Be sure and back up and watch video number 485, which is more general, just about hole saws, the different types, and how to use them. So let's get started right away on sawing some big holes at relatively slow speeds, or should I say the correct speeds. If you've done any metalworking at all, I think you know that you can run the saws or the drills much faster for small holes than for large holes. So looking at these, well, there's four of them here, but I'm going to talk about the two largest ones. This is 3.5 and this is 4 1/4. Now I bought these two years and years ago, I mean 40 years ago, when I was making the Peterson micrometer teaching aid, and there are wooden plugs in there. On the very end right here, there's a wooden plug made out of a 2x6, so I would saw them out with this. And imagine that was a pretty big plug, and I would end up with a 1/4-inch hole, and then the 1/4-inch hole would be enlarged to 7/8, put on an arbor, and turned in on the lathe to, well, it was less than 4 1/4, perhaps it was 4 1/8, I don't remember. Now I gave up on that eventually after a few hundred of them because it was so slow and laborious to do that. It was faster to bandsaw them, and I developed a jig for bandsawing those discs out real fast, and they were still rough sawn and had to be turned on the lathe. So I gave up on that one after not too many uses, and the other reason is I could not at that time get my drill presses to run slow enough. However, I did make 10,000 of the 3-inch plugs with this 3.5-inch hole saw, so you can see that that's got a lot of wear on it, but it's still in good shape because I used it only for wood. Now, looking at the steric chart, it's probably too small for you to see, but one of these comes in each box. Some directions on that side, but it's a speed chart on the back. But for the 3.5-inch here, looking down here, it calls for 95 RPM for mild steel and 155 about for aluminum, or I got 145 written on there. 145 and 95 for steel, so I marked that. Now the old 480 in green there, that was something I wrote on there 40 years ago for the drill presses, for the job that I was doing. Because I would make up hundreds of those at a time and then may not have to do it again for a year. Same thing with well, no, not the same thing. The 4 1/4 requires 80 RPM for steel and 120 RPM for aluminum to get the approximate 100 feet per minute that I always talk about for steel. And I didn't really do the research on that. I'm just going by what these charts say. So you can find the speed for every one of these. Now your drill presses aren't going to run slow enough for these big ones, and that again is what this video is all about. I'm at the Walker Turner drill press that was featured in many of the recent videos, and remember that I have a DC motor on here so I can adjust the speed, but remember I had a problem also with torque. So with the larger diameters here, perhaps I'm going to stall it, but I presently have it set on about 480 RPM, which is what I used to use, the speed I used to use for wood when I was making the big micrometer. So just to bring back bad memories to myself, I'm going to go ahead and saw out one of the plugs. And I had to saw from both sides, so I would go about 3/4 from one side and then flip it over and finish from the other side. Also notice that I generally allowed the saw to hang over a little bit, which would produce a little bit of a flat spot, but I didn't care because I was going to turn it down on the lathe. But the purpose of that was to get the sawdust out of there. Otherwise, you've got to keep backing off to allow the sawdust or the swarf to get out of the kerf. Here I go, 480 RPM. Then I would flip it over. And it was always a fight to get that plug out of there, but you see there's a little bit of a flat there. But since it's going to be reduced in diameter on the lathe, that wouldn't matter. Even if I ended up with a little flat there, it was hidden on the inside of the micrometer. It would not have mattered. Now I did 10,000 that way. I'm just showing you this because of, and it didn't tend to bog down at all, did it? At 480 RPM. And that's of course just an average fir 2x4. All right, let's do some steel and aluminum. I will saw some 1/4 inch thick aluminum with a 2-inch Starrett hole saw, and the speed recommended is 255. I'll be using WD-40 as a lubricant, and remember that this lathe, this drill press, has a tachometer on it, so that's how I'm determining the speed. That was shown in other videos as well. So let's see what it does here, or if it will stall at that RPM. That's no good at all. I'm only about halfway through, and you can see the torque is just not there with this DC motor. So I'm extremely disappointed. Backing up here just a second, I'm still at the Walker Turner drill press here, and again I'm disappointed in the direct current motor and the lack of torque at low speeds. So later on, and probably not even shown in a video, I do intend to change the pulley back here so that the motor will be running at a little bit faster speed, and experiment with that to see if I can get greater torque at the spindle. And that's still to be determined, and that's going to be an experiment. I'm out in the garage now with the Duro drill press that has the pull gear on it. Remember, it runs at 250 RPM, and I will continue with the hole in the aluminum and see how that works. And that worked fine. I could not stall it, and it's probably too hot for me to try to take the plug out right now. Also remember now, with hole saws, let's just say that I decided, oh, that hole's not big enough. I want to make it 2 3/8. You could not go in there with the larger one because you no longer have the support of the drill in the center hole. So it's a one shot. All right, now let's do steel and see what happens. And I'm going to have to run it at 250, even though I would like to run it at 170 for steel. But the speed was just right on this Duro for the aluminum, wasn't it? 250 as opposed to the 255 that it called for. This is 1/8 inch mild steel, again 2 inch, and I'm running at 250 RPM, clamped in 2 places with wood underneath so you don't drill into the table always. And remember, that speed is way too fast for steel. It should be 170, so let's see what happens. And I'm just going to use regular cutting oil as a lubricant. Actually, that was too good to be true. A few blue chips, but overall a very nice job at that speed and steel. Admittedly, it's not a real thick piece, but quite often that's what you're doing. You're just going through thinner stock with large hole saws. Well, that's all I can do on these drill presses as far as getting it slowed down, but there was no tendency for this at all to stall out on me. So the pull gear really is a great feature in my shop. But I'm going to go back into the basement and with the Bridgeport mill and back gears, run it at slow speed with yet a larger hole saw, and we'll see how that holds up. Now let's step it up a notch, and this is a 3.5 inch diameter Starrett hole saw, and I'm at the Bridgeport mill. I'm in back gears at 135 RPM, which is, and Starrett calls for 145, but this is the closest I can come with the Bridgeport. But let's take a look at how many feet per minute we're cutting at. And I already measured it. It'll be about 115 using the tachometer. I'm going to measure this way, it works better. You can see I'm directly reading here now at 115 RPM, which is really slower than what it should be for aluminum, but nevertheless. And this is a great way to go on the Bridgeport, but several things you need to note. Be sure and put a piece of wood under here, and I've already aligned it such that the pilot drill will go into one of the slots, not into the table proper. Remember that when using the Bridgeport in back gears, you have to run the motor in reverse, and I'm using a little WD-40 as lubricant. Works pretty good. Pretty well. I said reverse. Now, when you saw the saw stall, the belt was slipping is what was happening. And I'm all the way through. It was rather slow and laborious, wasn't it? Hot, hot, hot. But there it is. I think I'll use the halo light here, my hound dog, to brighten it up a bit. Now, several points I want to make here. This is 1/8 inch steel, and again I got the wood under here, and I've clamped it securely. It looks like one of the clamps slipped a little bit last time, but there's just an awful lot of torque going on here, and there's a lot of places for it to slip. I think perhaps the chuck slipped a little bit in the collet, the belt slipped, you know, any place we can have a little failure, that's going to happen. But with the steel now, Starrett calls for 95 RPM in their chart. but the closest I can come with the Bridgeport is 80 RPM, and I already checked it with the tachometer. That comes to 60 feet per minute. I expect this to be a great struggle, really, to cut this out, and I'm using regular cutting oil. But let me point out, notice that there's a bit of a lope in the saw here, because I suppose it's worn and all of that, but because of that, it's cutting an extra wide kerf, which means really I'm removing a lot of material. And here I go, and I expected this to take quite a while, so I'll probably speed up the video for that purpose, to cut the boredom. Okay, that wasn't as bad as I thought it would be. Matter of fact, not much harder than cutting the aluminum, although this is a little thinner. Remember, this is an experiment. It's I'm experimenting here and demonstrating at the same time, so you know, if you got to cut a big hole, that's the way you got to do it. And you probably wouldn't have much luck with a portable type electric drill with this, but it did work pretty well here on the Bridgeport, and everything is hotter than a pistol. Let me knock that slug out of there. Let me point out that if you are going to drill a whole series of holes, make sure that you remove the slug. Don't let them build up inside there. Not only will they be in the way, but there'll be a heck of a job getting them out of there if you got a whole stack of them. But there it is, and it's too hot to touch. Let's compare it with the aluminum one. Well, that one's cooled off now. And what kind of hole did we actually get here? Quite a nice one. This is pretty warm. I did run it on purpose into the other one so that the swarf could escape, but depending on what your job is, you may not be able to do that. But keep raising the saw to clear the chips. And there's the two holes in the aluminum. Somewhat of a burr that would have to be removed, but that's expected. I would say do not expect to do these real large hole saws on a small drill press. It just isn't going to work. You're not going to have the power that you need, and you're not going to have the slow enough speed that you need. And you saw me struggle even with a 2-inch one on the smaller drill presses. So this ideally would be the way to go, because you got back gears here, but of course not everybody has a milling machine, and I understand that, but this whole thing is a grand experiment in the demonstration. Well, I hope you learned something in this video, because in fact I did, and it's an interesting concept to use hole saws, but they're expensive, and I would say relatively hard to use in the larger sizes. That's my conclusion here, and I seldom use the large sizes, as I just said. So hope you enjoyed the video, and I'll see you in my many other videos.